Next on Web Dev Ladder, I'm going to walk through the conversion I did in one of my apps named EarBetter, which is an ear trainer, over from a stores compatible implementation called Preact Signals over to Svelte 5 runes, which are also signals based. So I'm going to really quickly go through the app, and then we're going to get into the details about the differences that in syntax and a few semantic differences between Preact and Svelte 5 runes, Preact signals, that is. So I'm going to shrink myself down. Over here in the app, I'm just going to give you a very quick overview of what this app can do. Here's like a piano. You can also play a MIDI keyboard. The main part of this app is the ear trainer. And so I'm not going to do too much here, but I will give you a very quick demonstration. The basic idea here is that it's prompting me to respond to the sequence of notes that I just heard and kind of play back what I just heard. So I was correct. That's also correct. I'm just going to go ahead and skip ahead and win. So basically this will track your scores. Here's an easy one to start with. If you have feedback on the actual app, I'd love to hear it. The YouTube comments or Discord are both great for that. It has a lot of customization. I spent quite a lot of time thinking about the design of this thing before I implemented it. And then I started about a year and a half ago. And it mostly has been stable in terms of design. But I'm sure there's a ton more I can improve. And I would love to have help with that. So basically, I'm going to walk through a bunch of stuff to explain what we're dealing with here. First, here's the GitHub repo where I have EarBetter. You can see some of these pull requests that I went through. I'm actually going to pull up one of them that I forgot to pull up. So we'll deal with this in a sec. The basic idea is that I converted from using stores, which use this signals library under the hood, because what it provides is a store contract compatible library that is a wrapper with these objects that have a subscribe method, which you might have heard of with our Svelte 5 stores that we know and love. With Svelte 5 runes, which you might have heard of, these also use signals under the hood. And so the idea behind signals is very similar between these two libraries. Runes will have a few different differences that we'll get into, but the basic idea is that runes provide a signals implementation additionally with some really syntactic niceties that I'm going to give an analysis of in the pull request at the in a little bit. So first, let's talk about the actual semantic differences between Preact signals and runes-based signals in Svelte. So the basic idea here is that Preact signals have some subtle but very important differences. What I'm going to show you here is these first 5 logged lines of code are in this block of code. So what we're doing is creating 2 signals, A and B, and then we can create a computed signal, which is going to concatenate A and B together. You can think of first name, last name. We then run an effect, which says, hey, when any of this, when this value changes, I want you to run this effect and log out what we're doing. So all of these logs are logging out because they're in effects. We then assign a new value to A and assign a new value to B. We just uppercase it. So it goes from lowercase a to uppercase A. And notice a problem here. This intermediate state right here, I believe is known as glitching. What this idea is that because of the way Preact signals is eagerly evaluating these signals from step 1 to step 2 to step 3, where we start assigning new values, the problem is we have an intermediate state that makes no sense. We never should see A and B together, right? Instead, as we see down here and down here, we only should see 2 log statements if we want a non-glitching implementation. And but this is because say you make an API call with this intermediate value that's nonsense, that's a problem. You're gonna have bugs, and your server's gonna receive things that makes no sense. So Preact has a very simple way to fix this. It's called batch. So if you wrap this exact same code as above, but instead of just assigning these values like this, we're wrapping it in a batch call. And so the code reads exactly the same. And notice here we enter and exit, and there's only 4 lines logged, and there's no glitching state. This is because we now call it batch. So looking at the Svelte implementation, there's actually an important difference here to pay attention to first that we'll look at is we say enter Svelte 5 runes, exit, enter Svelte 5 stores, exit. So notice this is actually deferred to the next micro task or to some later time. So unlike with batch even, we don't actually get, notice we exited after logging out with preact, but with Svelte, we're exiting first. And then later on, after the micro task, or at the end of the micro task, we are logging our values. So notice that Svelte 5 runes are batched by default, which was a really good thing in my opinion. I think that like glitchy states and needing to call batch manually is very error prone, and it's also has really significant negative effects to your code, as I can show you right now. So actually, I did some prep work for this, the PR that we'll actually analyze, where I removed batch in a completely standalone PR. The reason is I wanted this to be a fair comparison and also a not noisy comparison. So if we look through this batch PR, what we can see is that all we're doing is removing this batch call and unnesting the contents of these callback functions. So batch takes a function and we just are pulling that out and unnesting it. That's all this pull request does, but you can see it creates just a ton of churn. We did not want the analysis to be that noisy. So you can see that like it removed like 60 lines of code. That might be slightly unfair, but that's the gist of it. Like batch is both error prone and noisy and just extra things to worry about that Svelte 5 just kind of solves for us, right? No glitching with Svelte 5, either stores, and nor were stores. Notice I did a stores one as well, where we used the derived store and an effect. No glitching. So we can now hop over to our actual pull request. So this is, I'll give like a kind of a walkthrough of all of the details I could pull out of this. If I miss any details, I would love to hear about it. Please let me know. Again, YouTube comments or find the Discord. So what we're gonna do, I'm gonna just make sure this is expanded. Okay, it is. What I'm gonna do is kind of start from the very simplest possible point and show you some of the syntactic differences. So this one right here, if we go to this link, it'll show us that all we did to convert from in a component, so we're at the root level of a component inside the script block, and we're saying, we used to say const min note equals signal some value. And this might look familiar if you could have just like put writable there and it would basically work the same for our purposes that we're looking at right now. So it's constant because we're not going to reassign it. And then it's a wrapper called signal, which just creates a store compatible object that holds this value. And then notice we changed it to let and then just $state. So in the case of let, we had to say let because we're now going to reassign this value. It's no longer boxed where we can call like .set or $min note equals like we could with assignment with stores. Now we have to just assign it directly. There's no wrapper, so we're going to actually need to call let because we are going to reassign it. Next, we'll look at the computed versus derived differences. So computed and derived, there's one really important thing to pay attention to here besides the name. The names are obviously slightly different. The idea is that computed requires a callback function, and this is because it's plain JavaScript. It needs to rerun this over and over and over. Every time its dependencies change, it's going to call your function, get the value, put it in this box, and you can use it like any other signal. With the case of Svelte 5 runes, they're able to pull a little magic trick where they were able to remove the outer function and just let you put in any expression you want here because there is no, they're using a compiler. There's no need for you to have to provide that extra wrapper function. They can do whatever they need under the hood. Maybe it's a wrapper function, maybe it's not, to implement this without this running eagerly. If this was plain JavaScript and not runes, notice we're in a .svelte file. So it's app.svelte.ts. So this .svelte infix allows us to use runes inside of .ts files. But the syntax is identical to what you would see in a Svelte file as well. Except for, yeah, it's on a class, but that's kind of a detail. So the idea is that you actually just don't need that extra nesting. You can just put an expression here. It looks like it's evaluating eagerly if you don't know what you're looking at, but because you see $derived, you know, oh, cool, this is just like the most terse way to define this. So next we're going to look at the third and final primitive of signals. It's called effect. All we had to do was go from effect to $effect. That's all it is. Exactly the same. There's one more slight difference. Just to point out, untracked versus untracked. So untracked is something that both Svelte and Preact signals have. Basically, this lets you have a non-reactive read. This is not a good example because I didn't actually, this was a bug that I made when I was converting it, not to the runes, but to Svelte 5 components. So don't pay attention to this in terms of the code, but untracked becomes untrack. Works the same. So one of the other very simple things we can pay attention to is that we no longer need imports. So we're in here, a level.svelte.ts file. It's, like I said, has that svelte infix in the extension. And we no longer need to import our signals stuff. The runes don't need to be imported. Runes are automatically added whenever they're used, both to Svelte components as well as .svelte.ts or JS files. So it's just a little nice thing. Runes are just kind of available when you need them. So the next thing we can look at that has a lot of implications is no boxing. So like we already kind of saw, there is no extra layer between you and your declared reactive state. So instead of saying signal and wrapping some value and getting a signal wrapped status here, we just say state to the value and get the value type directly. There is no extra box around stuff. And this has, not only is it a little bit nice, it also has a lot of downstream implications because of this behavior. So the first of those that I'll explain is there is no .value for reads. So as you can see in this expression, we're doing a computed value, and here we just make a derived value. And these are exactly the same, except number one, we no longer have the extra outer function wrapper like I pointed out. And then number two, we don't have this inner .value anymore. So for reactive reads of properties of reactive data, you no longer need to have this extra like .get in some implementations or .value or whatever it might be. You're just using it directly, which is really nice, both in terms of like writing it, but also just reading code. There's no extra noise around here. The same is true for writes as well. Instead of saying this.trial.value, I can just say this.trial equals. So there's no .value. Just like with reads, with writes, there's no extra noise. This has like a subtle implication with like, you can use certain shorthands like plus equals. I probably could have used plus equals here. So this is like not a super fair comparison. I probably could have said value plus equals 1. But I wanted to communicate this as a non-reactive read. But this is also a reactive read. So it actually is not a fair comparison here. But the point is the same, that like you can use certain shorthands much more clearly. There is no .peak, so this .peak is a non-reactive read. There is no equivalent in Svelte. Untrack and untracked basically do the same thing, but a little bit more verbosely, which is fine because untrack is generally not what you want to be reaching for in most cases. A lot of the time, if you see untracked, that means you could probably restructure your code to not be using effects. But the idea here was that in the start function, I wanted to non-reactively read this status value. I was previously peaking it, and there just is no equivalent. And in this case, I did not need to make it non-reactive because start is not being called in an effect. So I knew this was safe to do because I checked. But this is like a downside of using Svelte 5 runes. There's just not this ability to communicate intent quite the same. But it's both an upside and downside. I think it's more subtle than that. Kind of one of the things that I just thought of recently, today even, I haven't given it too much thought, but this idea of, if you've heard of what color is your function, is a well-known blog post that talks about this difference between synchronous functions in JavaScript versus asynchronous functions in JavaScript. And the fact that you can't use an asynchronous function in the place that you might want to use a synchronous function. So there's these two different function colors that kind of are different from each other, and you can't just like use them interchangeably like you can in a language like Golang, where you can do concurrency with the code. Like you can have a helper that might be concurrent or not. It's similar in Svelte 5, where these are kind of, the way I'm thinking about it is like colorless reactivity, where you don't know if this code is being run in a reactive context or not, and you don't have to know, which is, I think, both good and bad. I think I actually don't mind a lot of the time having colored async functions in JavaScript. I think it can often be really important and helpful to know that I'm dealing with something that's not synchronous. But there's trade-offs. There's definitely you can't just write code that works in both contexts. You can one direction but not the other. You can't use an async function where you expect a synchronous function. In Svelte 5 runes, you kind of had this like colorless reactivity where you can just write code that looks like, I don't know if it's reactive or not. It really depends on the caller. I think it has really nice ergonomic benefits. There's also a few trade-offs, like the intent is a little bit less clear. You could always use an untrack if you want to be super defensive, but that's probably an anti-pattern. But this idea is kind of pervasive, and this idea of colorless reactivity seems like pretty important to understand the implications of Svelte 5 runes, because there's no .peak, there's no .value, there's no .set, there's no .get, right? There's just you accessing properties and setting properties, just like everything else, right? I have no idea if this is reactive or not. If I look at the declaration site, though, I do know this .trial is going to be reactive, because trial is defined with, we can go look at it, is defined with $state, which I believe, in my opinion, is the most important part about declaring reactivity, having it on the declaration site. So communicating reactivity, having it on the declaration site feels like the most important piece of this. So in other words, the colorless reactivity, although it has some downsides, I think it's mostly benefits. It makes everything kind of really sort of like unified across your code base, which is one of the main benefits of Svelte 5. We now just get to write the same code, whether we're in Svelte files or .svelte.ts files. So one of the other implications of this is that we can use, instead of store syntax, where we had to say like $min note. Remember, we declared a signal with min note up here that we then changed, right? So min note, max note were signals, they're now state. So now we no longer access them with the $sign. So if it's component local state, we were able to actually use the shorthand. We no longer, even though this was the exact same name, min note, we had to $prefix it. And there was no special Svelte syntax for forwarding the, like say, shorthand min note as a store. So we had to be like this more verbose form. So a little syntactic nicety if we're dealing with component local state. However, that actually has the opposite effect if it's not component local state. So here's an example where we want to deal with some level properties that are reactive. Remember that, like things like the trial. So previously I was deriving this data off of the level, and it was reading that data reactively because they were stores, and it could just pull off these stores, and then we could like pass them around and use them directly. But now we lose reactivity if you destructure like this. So doing this was actually a bug converting to Svelte 5 runes. When I converted because these are no longer stores that I can reactively update by calling methods on them. Instead, they're now plain data. And so what that means is that like we lost some shorthand. Just like I showed you, we gained some shorthand in one place. We lose some shorthand in places now. So instead of being able to just call MIDI access, which was a reactively destructured property off of the app, so MIDI access was pulled off right here, it's now, we were able to use the shorthand before, and now we no longer can, because if we had destructured MIDI access off the app, we would not have gotten reactive updates when that property was set. By destructuring, we sort of, because that's just how JavaScript works, it used the getter immediately and then no longer was accessing the getter during the reactive runs, during the effects, in which case this was rendered. Meaning, we now had to add app dot. In a lot of places where we're destructuring, as you can see up here as well, I had to access these values because I wanted them to be reactive. Now, technically, a lot of these probably did not need to be reactive. Like play is not called in an effect, so probably I could have destructured a lot of these. But this one is a good example of where I did lose a little bit of nice syntactic niceties. There's definitely probably ways to restructure this code, but the idea is that I couldn't destructure off of a class and have it stay reactive in this particular component. I could have if it was a prop. So the next one we'll deal with is there's a non-null assertion for state in the constructors. So this might be solved with an improvement to Svelte 5, but right now it's not. Basically, I'm declaring this app data on the instance, the class instance, and I'm initializing it to a frozen piece of reactive state. The problem is I don't actually get the value for that until the constructor. So I'm scrolling way down here. App data is set with this.load. The problem is because of initialization order, if I inlined this.load up here, it was throwing an error. So I actually had to do this.load in the constructor. I could have the benefit, or the improvement that I was saying that might happen is that app.data could possibly be declared in the constructor. And so I wouldn't have to use this like little bit funky syntax where I'm saying, hey, trust me, I'm going to reassign this thing in the constructor. So you don't have to worry about it not being defined. Because this being undefined, I needed this exclamation mark to satisfy the type. I did not want this to be, the type of this to be possibly undefined. All right, so we're getting close to the end. One of the things that I liked about .peak was it allowed me to kind of communicate my intent, but it colors the reactivity. Whenever you saw that .peak, that meant, hey, like this is you're dealing with a value that has to be reactive, and you have to read it in a non-reactive context, which means that you're taking a little bit of way of control from the parent. You're also making your data structures less flexible because you're forcing one particular implementation of the wrapper. Also, like untrack is more verbose than peak, which can be a downside. I think it's not so bad because, like I think I said already, untrack is probably a code smell in a lot of cases. So if you're calling untrack, maybe that's a signal you could restructure, rethink your code to not use the effects that cause you to need untrack. So far, I found a bunch of places where I had written old code, converting it over to Svelte 5. I was doing certain patterns that were probably ill-advised and probably were more buggy than I thought. And so Svelte 5 kind of really nudges you towards being much more declarative. For example, one of the main anti-patterns is setting state inside an effect. Don't want to be doing that because you can really tie yourself in knots. So overall, runes I think are wonderful. I think they shine even more, not in this app, but in more complex situations where you're composing sort of large data structures that have a lot of nesting or other things and reactivity that's all over the place. Especially stores were very unwieldy for these kind of use cases. Yeah, if there's anything I missed, I think that's it that I was able to see in this pass. So if you see anything else, please leave comments or hop in Discord, and I'll see you next time.